So let's finish up this lesson on functions. This is the page that we're on. A few new words we learned. Remember, all the first elements or first values, if they're numbers in a relation, is called the domain of the relation. All the second values or elements is called the range of the relation. And then we talk specifically about a certain type of relation called a function, where every x value has only one corresponding y value. The x values or the domain values never repeat. So the last thing we'll talk about with functions is we use a certain type of mathematical notation with them. So you guys are used to seeing something like this. So if I give you, you don't have to write this down. If I give you this, and if I tell you x is 1, you can tell me what y is, right? So if I say x is 1, 2 times 1 is 2, plus 1, y is 3. This is a relation, okay? It's also a function. So like if I gave you the same thing, and then asked you to plug in 2, it performs the calculations, and it spits out the answer, except function notation is a little bit different. We no longer use y. We use this notation. And this reads f of x. That's how you read it. It doesn't mean multiply. Okay? These two mean the exact same thing. This is just relation notation. This is function notation. How can you tell it's function? Because it's got this fancy notation. That's the only difference. Okay? So for example, on the previous page, when we talked about hours worked and the gross pay that you get, okay, we saw that that was a relation, obviously, because it's relating two variables. And we also saw it's a function because the domain values never repeat. You can't work 2 hours and get paid 2 different amounts. That doesn't make sense. Okay. So if we use that in function notation, so what we would normally do is we would say, okay, capital P, your gross pay, is equal to 9.5 times h, the hours that you work. Okay. But now we're going to use function notation, which doesn't change much. So what we do is we plug in the number of hours worked. Okay. It performs the gross pay calculation. And then instead of just capital P, out pops P of H, or P as a function of H. And again, we read it like P of, and it doesn't mean multiply. So all we're doing with this is using a different notation. Okay? There's really no new math here. So let's say we wanted to take that function notation, okay? And we wanted to calculate a person's gross pay for 25 hours worked. Well, what we would do is we've got the function notation, P of H is equal to 9.5 times H. I want to find P of 25. That means plug 25 in for H. So it's 9.5 times 25. Therefore, P as your pay as a function of 25 hours worked is 9.5 times 25, which gives us, I don't have that off the top of my head. What does that give us? $237.50. So all you have to do to convert from a regular relation equation to a function one is just use the letters in the equation. So like, for example, if I said m equals 2 times k minus 7, that's relation notation. To change it to function notation, all I do is change the m to m of this variable. M of k equals 2k minus 7. That's function notation, but they do the same thing. Okay? So that's how we convert. So if we wanted to do another one, if I said, I don't know, h of, h equals 15 plus 7 m. That's relation notation. For function notation, all you do is instead of calling it h, you call it h of n. And you write the same expression on the right-hand side. The only one that's a little weird is when you have an equation that has y and x in it. So if you had y equals x minus 10, that's relation notation. To change this one to function notation, we don't write y of x, we actually write f of x. So that's kind of a special case. But we do the same operations with them. We do the same things with them. So let's look at a couple of examples. So here we have an equation, v equals negative 0.08 d plus 50. It actually represents something. It represents the volume of gas remaining in a vehicle's tank after traveling d kilometers. Right now, this is in relation notation. How can I tell it's in relation? Because it doesn't have the parentheses here with b on the left. That's all. So what's the function? Well, describing the function is that the volume is a function. Volume v is a function of distance traveled, which is little d. And how do I rewrite this equation using function notation? All I do is change the left-hand side. Instead of v, I put v of d. That's it. The right side of the equation doesn't change. So that's what it looks like in function notation. Okay. Now let's use this equation in function notation to answer a couple of questions. Well, you are asked to find b of 600. Well, what did 600 replace here? It replaced d. So b of 600 is negative 0.08 times d, which you are told is 600, plus 500, and you can calculate that. Yeah. What? Oh, 50, sorry. Thank you. So negative 0.08 times 600, and then if you add $50, or add 50, sorry, $50, you get 2. Okay? So what does that mean? Well, we drove 600 kilometers. That means 2 liters are left in the tank. Because remember, V is the volume that remains in the tank. So after you drive 600 kilometers, or travel 600 kilometers, okay, you got 2 liters left in the tank. Now, this second question, you got to be careful with, because you're not told what D is. You're told what V of D is. So you don't replace this. You replace the whole thing with 26. You were told replace V of D with 26, and then figure out what D is. So that turns it into an equation. And we have to solve for D. Well, how do I go about solving for D? What would I do first to get D by itself? Subtract 50, subtract 50, and I get negative 24 is equal to negative 0.08 times D. And then divide both sides by negative 0.08. And I will get D is equal to 300, I believe. Yeah. And that's kilometers. So you travel, so what does that mean? That means when you travel 300 kilometers, you've got 26 liters left in the tank. Okay? So 300 kilometers travels leaves 26 liters in the tank. Let's look at one more. And here, we're already given the equation in function notation. How can I tell it's function notation? Because it's got this f of x. So we've got to make sure we can tell the difference between these two questions. In this question, you're not told what f of x is, you're just told what x is. Okay? Because the 2 replaces the x. So I am asked to replace the x with 2. Like so. That's what I'm asked to do in the first one. But in the second one, I'm not asked to replace just x. I'm asked to replace the whole thing, f of x, with 8. And figure out what x is. Notice the difference between the two. One is just a straight calculation. 2 turns into an equation. So this one, you just do 3 times 2 minus 7, and you get negative 1. Straight calculation. But this one you have to solve. So we have to add 7 to both sides to get 15 is equal to 3x. Divide both sides by 3 to get x by itself. And x is equal to 5. Okay. So that's using function notation. And we're going to see a lot more of that in the next couple of years. Right? Like, for example, I mean, you guys know how to graph, you don't have to write this down. You guys know how to graph this. Okay? Well, now the notation is just going to change slightly. You're going to be asked to graph this. Just remember that f of x is the same as y. It's just notation. That's all it is. Okay, but we'll get to that. Okay.